Good morning. This is Dhanlakshmi, Assistant Professor of CS Department and from Kogonada College of Engineering and Technology. Today we are going to discuss about the Unit 1 for Design and Analysis of the Algorithm. The first unit is the introduction. Here we are going to study about the algorithm and how to write the algorithm and what are the important properties of algorithm and how we are going to analyze the algorithm based on some mathematical notation. First of all, the introduction. Here, what is the algorithm means? It is a finite set of rules or instructions to be followed for a particular problem solving. It is a step by step, or otherwise, it is a step by step procedure to tell about how to solve a particular algorithm. So, this is what your introduction about the algorithm. Some of the algorithm involves the recursive operations as well. So this is what the notion of the algorithm. So before that we are going to see about what are the how to write the algorithm, what are the steps for writing an algorithm. First of all, algorithm is a procedure, so it has a two different parts. The first part is head, the second is body. The head section consists of the keyword, has just nothing but your algorithm and name, and what are all the inputs, and what will be your output. So those things are said in the or discussed in the head part itself. For example, algorithm name, problem description, input and output. In the body of the algorithm, we can include various programming constructs like if else, for loop, decision making statements, assignments, and so on. The fourth important one is the compound statements. If you are going to deal with the compound statements, you have to enclose within a closed and open braces. And command line also used at the beginning of the algorithm. So here the left arrow is used as an assignment operator. So this is what your notion of an algorithm. Here's an example of how the algorithm is written for finding the largest number from a given list. For your input is a the user have to give a list of numbers in the list L. The output will be the largest number which is in the given list. So first of all, we have to assign 0 for the variable largest for each and every item, just each and every element in the list. We have to do the for loop operation. If the particular item is encountered, if it is compared with the largest item, if it is largest means the item is placed in the largest variable and return the largest variable. This is what we algorithm explain steps for example for writing a algorithm. Then this is the fundamentals of algorithmic problem solving. So how the algorithm will be discussed here. First, we have to understand the problem. This is nothing but the phase one of software engineering. The basic step is requirement analysis and design, and this next step is how to solve the problem based on either a computational means, which is an exact as well as versus approximate method, and based on that technique we have to design an algorithm. And if it is checking for an error, if it will be for error means we have to prove the correctness, and we have to analyze the algorithm again and code the algorithm based on the corrected algorithm. So this all we have to show various types of important problems in algorithm design. So first we have to see a few only of them. First one is the sorting. The sorting, which is nothing but you have to rearrange the item of a given element in the given list in some order, either it will be ascending or descending order. So we have to deal with the n number of sorting techniques like quick sort, merge sort, insertion sort. For each and every sorting has its own unique time and space efficiency. And the next one is the searching. For searching also we have a n number of searching techniques like binary search. So here we have used the search key in order to find out the elements in a particular list. For example, for a quick sort we have to choose a pivot element that is used as a key for searching the entire element in the list. But the limited binary search algorithms are representing the underlying set, which is from form a more conducive to the searching. So combinatorial problems is nothing but based on a given element, we have to select a particular element based on certain conditions. The solutions could be reached by manipulating a numerous sub-solutions or partial solutions. The major topic for the analysis is the asymptotic notations and its properties. The asymptotic notation is nothing but it is a rate of growth between the defined functions as well as the defining functions. So it is a nothing but a mathematical tool to analyze the algorithm based on a number of factors like input size, recursive function, that's all. And it is a one way to express the algorithm's behavior in terms of space or time complexity. So we have a three basic types or three orders of growth for asymptotic notation: big O, big omega, and big theta. We have to give a two different functions: non-negative function t of n and g of n. T of n is nothing but your algorithm's running time, which is indicated by this basic operation count c of n. So g of n is nothing but your given function to solve a particular problem. The first theta notation, which is nothing but it represents the upper and the lower bound of the algorithm running time. It is mainly used for calculating the average case complexity. For example, it can be represented as the function f of n is lies between the g of n and the t of n, because in this it represents the functions lies between the upper bound and the lower bound of the algorithm. So next, the big O. The big O notation represents the upper bound turning time of an algorithm. So it gives the worst case complexity. It means it takes a longer time to run a particular algorithm. So it specifies the upper bound. It denotes the maximum time required by an algorithm to produce the output. So it is allows the algorithm to complete the statement execution in the longest amount of time possible. So here we can able to see that the function is lies below the time complexity of the upper bound. The omega notation, it represents the lower bound run of the running time of an algorithm. It is mainly used in the case of it provides the best case complexity of an algorithm. So it takes a shortest time to run a particular algorithm. So here we can able to see that the function which is run above the lower bound of the algorithm. So these are the analysis framework. These are it's nothing but your key parameters to measure the to measure or analyze the efficiency of algorithm. For the first parameter is based on the input size, we can able to analyze the algorithm running time as well as the space complexity. And second, units for measuring runtime just and the order of growth is nothing but your asymptotic notation. Based on that condition, we can able to divide the algorithm into either worst case, best case, or average case efficiencies. So it is a tabular column for the calculating basic efficiency classes. The one represent the constant value because it is a short of the best case. It represents the algorithm running time goes infinitely when its input size grows infinitely large. The constant will be happen when the output is fully dependent on the input size. The log n, which is logarithmic, it is mainly used in the divide and conquer method. The n linear, it scans the entire list of size n. Basically the linear efficiency will be calculated in case of searching and the sorting techniques. And log n linear algorithmic, mainly it is used in the divide and conquer algorithm. It is fall into the average case. N square for a quadratic, it is used when the two embedded loops has present in the particular algorithm. N cube, it's cubic. It characterizes the efficiency of algorithm with three embedded loops. To an exponential, it generates all possible subsets of the n element set, and factorial, it generates a permutation of an element set. Thank you.